So I'd like to talk about the role of attention in a theory of the unity of consciousness, though it's going to be a consequence of the theory that consciousness may not be always as unified as it seems. As a starting place, I want to say a little bit about what unity actually is, and there are various philosophical approaches to the very question. So what are we trying to deliver when we give a theory of unity in consciousness studies? And without reviewing all the options, I just want to appeal to an approach to unity that I find synthetic, which is a view that's been articulated by Tim Bain and with collaboration with Dave Chalmers. And the basic approach suggests that when we consider the unity of conscious experience, what we're really recognizing is that when we have a conscious experience, it can have multiple parts that are in some sense members of a single experiential state. So for two conscious states to be unified is for them to be subsumed under some other conscious state, some conscious state that has both of them as parts. So thinking about unity as a kind of subsumption, we would get the view that when you experience a cup of coffee visually and then also enjoy its fragrance, smell and vision combine together to form what is in some sense a single experience. So that notion of singularity of experience is the datum that I want to try to explain. From the perspective of our phenomenology, the idea is that when we have an experience, whether in one modality or several, there's a sense in which we can have a very, very complex phenomenal state where all the parts are nevertheless experienced as a single whole. And in this respect, one might think that the notion of the unity of consciousness relates to another concept in consciousness studies, which is the concept of binding. And binding is something I'm going to have occasion to return to, but at the get-go I want to register that it's important to actually distinguish these two. Because binding refers more narrowly to the ways in which multiple qualities might be seen as inhering in a single object. So when you find yourself at the bar and see the blue color of this exotic drink bound to the contours of this martini glass, you're having a bound experience of that beverage. You're binding together a certain visual property, color, with another visual property, form. And if you were to taste this beverage, there might be a cross-modal binding of the taste and the visual qualities. But here we don't have a single bound experience. Rather, with respect to bindings, we have multiple bindings. This bound object, this bound object, this bound object. So bindings are at the scale of objects. We think about bits of the visual world and the polysensory world as all occupying the same object in space. But we may have multiple objects in the scene which are not bound together. They're precisely unbound insofar as they're separate objects, yet they're part of a single unified experience. It's that possibility of an integrated experience despite a plurality of content that I think we want to explain. Now, people who've talked about unity, and here I'll refer again to Bain and Chalmers, have often entertained the possibility that experience is intrinsically or essentially bound. The idea would be that whenever we have a conscious state that has multiple components, they're bound together into a single coherent conscious whole. So the Unity Thesis refers to the idea that consciousness is always unified in this way. We can't have two simultaneous streams of consciousness that are not part of a single stream, that are not unified as one experience. I want to suggest that the Unity Thesis is false. So my main goal is to try and advance a particular view of the nature of binding, of unity, how unity occurs. But in so doing, I want to suggest that as a consequence of this theory of unity, that consciousness is not essentially always unified. Now, the theory of consciousness that I want to advance, the theory of unity that I want to advance, is based on a theory of consciousness that I and others have defended elsewhere. And the theory of consciousness stated most boldly is that consciousness just is attention. Now, that would need to be qualified in all kinds of ways, but the core that I want to preserve for our purposes is the idea that what renders a particular kind of mental state conscious is the modulation of attentional processes in the mind-brain. And I'm not going to spend time defending that theory here. I'll give some indication of the kind of literature that's led me to think that it's true. But I'm content with a kind of conditional thesis. And the conditional thesis is going to say that if consciousness is attention, if this equation between consciousness and attention is right, then there's a natural account of how unity arises. And that natural account of unity is going to turn out to violate the unity thesis. So we're going to build from a theory of consciousness to a theory of unity, and then use that theory of unity to come back to the question, is consciousness always everywhere unified? And our answer will be no. And I'll take up these themes in turn. Now, the relationship between consciousness and attention is controversial. And the people who deny the connection have developed very elaborate and interesting experiments to try and establish dissociation. In other works, I tried to review that experimental research and suggest that the prevailing interpretations are not the optimal ones, and that in fact there is no extant evidence for dissociation between consciousness and attention, suggesting that these two are one and the same. But the positive research linking consciousness to attention is what I want to mention here, and only briefly. The research program that really set off the interest in the link in the recent literature came from Mack and Roth, who coined the term inattentional blindness. And the experiments that they developed were building on a tradition in psychology called the dual task tradition, where people would be presented with two concurrent tasks. And attention researchers could show that performance of two tasks simultaneously leads to a competition, such that your capacity to perform one task optimally is impaired by the allocation of attentional resources to the other. Now, the limiting case of this would be one where the attentional resources demanded by one task are so great that there's no attention left for the other. And what Mack and Roth were able to show is that in certain experimental settings, this results in a kind of blindness. Presented with a task like this one, where subjects are asked to discriminate which of two intersecting lines is longer, subjects were so occupied with performing the primary attentionally demanding task that they failed to notice when the experimenters briefly presented an object in the center of the screen. The object might be a word, it might be a face, it might be a geometrical figure like this triangle here. So participants looking at these two lines and comparing them would fail to notice a briefly presented stimulus that would otherwise be readily visible. The inference, when we attend to one thing A, some other thing B that is not attended to is not available to consciousness. The suggestion is that attention is necessary for consciousness. Now, the very same research program can also be used to establish a kind of sufficiency claim. So imagine that the stimulus that's presented together with a crosshair is not a meaningless stimulus like a geometrical figure, but rather something that's important to the participant in the study, a stimulus that has ecological meaning, something that would demand our attention because of its significance. It turns out that prior to the allocation of attention and prior to consciousness, the visual system is able to do some object recognition and discern which features in our environment are worthy of our allocation of attention. We all know about the cocktail party effect, where when in a crowded room, a dim, a loud background sound that we're incapable of discerning suddenly becomes readily perceivable when we hear our own name. So a conversation that might have been inaudible at one moment becomes vividly audible if the people in the party across the room have mentioned our name. It turns out there's a visual analog of it. So our own tendency to recognize our names as stimuli worthy of our attention can be used to show that inattentional blindness fails when the briefly presented stimulus has this kind of ecological significance. When the stimulus is some arbitrary word, like the word house or the word tuba, it goes unnoticed. But when the word has ecological significance to the participant, like the participant's own name, it is seen. That should suggest that attention is sufficient for consciousness. When something demands our attention, consciousness seems to arise. Now, together with a huge body of research using multiple methodologies, including clinical findings, I think these kinds of studies suggest that attention is both necessary and sufficient for rendering our visual state conscious. So I want to take that as a kind of background starting place for thinking about what consciousness is. Now, before I can get back to unity, I need to say a little bit more about this theory, because the equation between consciousness and attention is underspecified until we say something about what attention is. And here, I think that the most compelling story about the nature of attention is an information processing story. The gist of which is that attention is a kind of gatekeeper. It's that which allows information to flow from one part of our information processing apparatus to another. In particular, attention is what allows things that are being perceived, information in our perceptual systems, to become available to a kind of short-term memory that's known in psychology as working memory. Attention gets information from perception into working memory. The basic idea here is that we're constantly bombarded by too many stimuli to actively think about. Working memory is a kind of executive memory system that temporarily stores information and then applies, usually in a serial way, various operations that can transform that information and use it for subsequent decision making. It's especially adapted for novel decisions, decisions that haven't been overlearned or over-rehearsed, new decisions where we can bring multiple sources of information to bear to make a strategic response to a novel or unexpected stimulus. The thought is that attention is a kind of filter that serves to determine which of the many things we're perceiving at any given time are candidates for that kind of further processing. And if you think about this notion of attention being a gateway to working memory, it makes a certain kind of prediction about what the brain should look like when we're having a conscious as opposed to unconscious experience. In particular, when we're conscious, we should tend to see a kind of circuit that involves your visual system or whatever sense modality you're using, structures that are associated with the allocation of attention, but also working memory structures, the target of attention, structures in lateral frontal cortex that would be involved in executive function in this kind of short-term storage. And if you survey the functional imaging literature on consciousness, you seem to see slides that look very similar, images that look very similar, because they're finding exactly that circuit. So when looking at various forms of change detection, the conditions under which a change is registered tend to show perception, some kind of attentional control in posterior or inferior parietal cortex, and then these lateral working memory structures. You can see that with masked as opposed to unmasked presentations of words. When a word is presented for a long enough duration to be seen prior to a mask, you see activation in sensory areas, attentional control, and again, working memory. When the word is processed unconsciously, you don't see that propagation beyond the sensory areas. There's one final example of this in studies of a phenomenon called attentional blink, where people fail to notice a stimulus after another stimulus that they've been searching for appears. The standard interpretation is that the first stimulus demands attention, it captures attention. And for a brief interval after attention has been captured, we're blind to what comes subsequently. Now, if you look at what occurs in conditions where the second stimulus actually goes above the conscious threshold and is consciously processed, again, you see perception, attention, and working memory. This looks very much like our circuit of consciousness. Now, that's at the level of gross anatomy. So what I've given you is some kind of cartological analysis of what attention is based on a psychological analysis of the primary function with respect to information flow. But we can go further. So there are multiple levels of analysis, and in thinking about the neural bases of consciousness, it's not all that constructive to point to an area of the brain and say consciousness happens here. Because every area of the brain can occur under both conscious and unconscious conditions. Really what we want to find out is what's going on in a particular brain area when we're conscious. We want to find the neural correlates, the actual neural properties of those bold signals shown in the last few slides. So the question about the neural correlates of consciousness that's been famously approached within consciousness studies really becomes a question, if this view is right, about the neural correlates of attention. And there, again, there would be much literature to review, but homing in on the theory that I have been most convinced by, there is a growing body of evidence linking attention to a certain kind of synchronized processing of cellular populations within our sensory system. And this is an old hypothesis in consciousness studies put to new use. It's the hypothesis that says consciousness arrives when you have synchronized activity of neurons at a range that's known as gamma, which is basically upwards of 30 hertz, 30 oscillations per second. Very often it's called the 40 hertz hypothesis because in some of the literature it's about that oscillation frequency, 40 times a second, that crops up when people are comparing conscious to unconscious conditions of perception. Strikingly, the 40 hertz signature has also shown up in attention studies. So if you're just trying to measure what's going on in the brain when we attend, you tend to find in a wide range of different studies that you see synchronized 40 hertz or gamma range activity under conditions of attention as opposed to inattention. So to take one illustration of that from a now classic study by Fries, monkey was trained to attend to one of two gradients. Cell populations associated with perception of those, a vertical and a horizontal, were identified in the brain, and electrodes planted in those areas of the brain were then used to measure the neuronal response when the monkey was attending to one as opposed to the other. And the key finding is that when the monkey attends to, say, a vertical gradient, the cells associated with perception of vertical lines start to fire in synchrony within the gamma range. The cells for the unattended stimulus, which is equally visible, is presented to the monkey, don't show that degree of synchrony or gamma response, suggesting that attention shifts the allocation of this particular kind of cellular response. Going inside of the nervous system, when creatures attend, we see an increase in neuronal activity. If you look at an fMRI study of attention, a property that's been observed for some time now, coming, for example, out of the work of Maurizio Corbetta, shows that attention increases bold. Attention increases metabolism within the brain. If you attend to color areas of the brain show greater levels of activation. Attend to form, and you'll see a different increase associated with form areas. Now, what is going on in this increase? You might think that the pyramidal cells associated with carrying perceptual information are the ones whose activity has somehow intensified under attentional load. But in fact, what you find is that attention is associated with an increase in what are called interneurons, which is a family of different kinds of cells that don't carry information about what's being perceived, but instead serve to modulate activity in these pyramidal cells. The interneurons are increasing in their activity, but interneurons are actually inhibitory in nature. So what you're getting is a big increase in activity in cells whose job it is to inhibit pyramidal activity. Now, why would this kind of inhibition occur under conditions of attention? We know from both in vivo and in vitro studies that neural inhibition produces gamma synchrony. So basically, introducing the kind of inhibitory signal associated with these interneurons is going to generate organized activity in the pyramidal cells. So if you think about this metaphorically, having some inhibition can get these cells in line. If you have lots of cells firing chaotically in different ways, but the ones that are firing out of sync get a kind of slap on the wrist, then you can increase the amount of synchrony. So the basic model would say that interneuron inhibition is going to lead to organization of activity within your pyramidal cells within the gamma range. And that at some neural level of description, some molecular level of description, is going to be an analysis of what goes on when we attend. Okay, so we've gone from an account that said, let's figure out what the psychological basis of consciousness is. We said that's attention. Then going from our behavioral studies, we said what's the roughly information processing role that attention plays, and we got a kind of computational story according to which attention involves the transfer of information from perception to working memory. And then moving from that level of what Marr might call algorithm, we asked a question about neural realization and got a story about synchronization of neurons. And the synchronization of neurons can now be scaled back up to the psychological story. And we can say, why does synchrony contribute to attention? Well, the answer is that synchrony allows for a kind of organized processing that facilitates information flow. If attention is availability from perception to working memory, we can see that synchrony is a very good implementation of exactly that process, because when neurons fire together, they're more able to send signals on to subsequent areas for processing. So that's the basic story, and I want to come back for a moment to binding. And the reason for this is the whole construct of gamma hertz oscillations has been most associated in consciousness studies with a view that equates consciousness and binding. So in the late 1980s, building on some work from German groups, Francis Crick and Christoph Koch advanced the following view. They said, consciousness always involves binding together of information. If we can find the neural correlate of binding, we can find the neural correlate of consciousness. And they went on to hypothesize that the neural correlate of binding is neural synchrony. And that led them to the view that consciousness is neural synchrony. Now, I'm advancing much the same view, but for the middleman there, the appeal to binding, I think needs to be jettisoned. In fact, for many years, I didn't think the binding theory could work precisely because I thought the connection between binding and consciousness was implausible. That led me to throw out the baby with the bathwater. I didn't think, and I think many people in the field didn't think, that the 40 Hertz hypothesis was plausible, precisely because 40 Hertz was presented to us as a theory of binding. And if you think that binding and consciousness are dissociable, you might infer that 40 Hertz and consciousness are dissociable. That's just what the empirical literature seems to show, and that, namely, that binding and consciousness are dissociable, and that conclusion, I think, led a lot of us, including Koch and Crick, to think that the 40 Hertz hypothesis was mistaken, and it was jettisoned by a large population in the literature. But we have to point out that that reason for rejecting the 40 Hertz theory of consciousness is, in fact, mistaken. The first thing to point out is that synchrony is empirically dissociable from binding. And if you look at the early studies that attempted to confirm the Crick and Koch hypothesis, they often had the following structure. You would present an animal, a laboratory animal, a monkey, typically, sometimes a cat, with a stimulus that had a component, an object that might be seen as bound, and then some other component, maybe a background pattern, that would be seen as unbound, as disconnected from that object, figure and ground. Now, figure and ground are a canonical example of an unbound pairing in a stimulus array. The figure is not bound to the background. They're two separate things. So the question is, what happens at the cellular level for neurons that are receiving information about the figure, the focal object in the array, and the background? If 40 Hertz explains binding, then we should find 40 Hertz synchrony for all the neurons that are responding to the figure, but no correlation between those firings and the cells that are responsive to the background. If a cell has its receptive field, some foreground objects like this roll of tape, and some background objects like this gray in the background, if 40 Hertz explain binding, this cell population should not correlate at 40 Hertz with this cell population. But the laboratories found just the opposite. They found that all the cells in our visual field seemed to correlate at 40 Hertz, seemed to be oscillating at the same frequency and in synchrony. So this suggested that 40 Hertz can't explain binding. So at this point, the temptation is to say synchrony is dissociable from binding, therefore synchrony can't be the basis of consciousness. But that inference, that syllogism, is based on the premise that this binding is the basis of consciousness. But that's just not so. So it's fairly easy to establish that binding is neither necessary nor sufficient for consciousness. Simply put, we have many bound percepts that never reach the conscious threshold. Every time you unconsciously perceive a complex stimulus, like a word, the bits that make up that stimulus, say the individual letters, need to be bound together. The very possibility of unconscious perception at the level of objects, when you're dealing with complex objects, establishes the possibility of binding in the absence of consciousness. The binding is clearly not sufficient for consciousness, but nor is it necessary. So you can find conditions under which people experience various objects with no binding or limited binding. Consider a pathological case. In the condition known as associative agnosia, also in some forms of apperceptive agnosia, individuals report being able to perceive the visual world, but they can't figure out which bits go together. A person with associative agnosia can faithfully copy a line drawing when presented with a figure, but they can't name the objects in that line drawing. Moreover, when they produce the line drawing, it's through a very painstaking process where they do it pixel by pixel, edge by edge, without seeing which edges are connected to each other. it looks like that might be a case of an unbound percept. And in ordinary experience, when stimuli are presented very quickly, for example, it seems possible to have an experience that's conscious where the binding that exists within that experience is limited, or in the extreme, maybe non-existent. Moreover, our best theories of how binding is achieved within the visual system typically appeal to various kinds of object models, often further downstream within visual processing, that organize the percept rather than something involving synchrony of neurons within a current perceptual state. What I want to suggest, though, is that any inference that says 40 hertz is not consciousness, based on the conclusion that 40 hertz dissociates from binding, should be rejected. Because 40 hertz is not a good theory of binding to begin with. 40 hertz and binding should not be connected, and binding and consciousness should not be connected. So the two ligaments that hold together the Crick and Koch theory just snap. But suppose we go with another suggestion that you can find even in those early Crick and Koch writings, which is a linkage between consciousness and attention. Forget about binding and ask, under what conditions are we conscious? Answer, when and only when we attend. Now ask, what's the neural correlate of attention? Turns out 40 hertz is a good conjecture. So we come full circle back to the 40 hertz view, but not via binding, rather via attention. Okay, that's to set up the basic theory of what consciousness is, and it's against the background of that theory that we can return to our key question, which is a question about unity. So consciousness is attention. How do we explain the unity of consciousness? Now, one way to approach this question is to say, on this theory, what constitutes a conscious state? I said unity, following Bain and Chalmers, involves subsumption. Two things are part of a unified state if they're part of the same state. So what constitutes a conscious state? And the answer is conscious states are populations of neurons that are synchronized together. Conscious states are attended states, and states that are subject to attention at a given time are synchronized. So we can think about synchrony as giving us a theory of what conscious states are, but thereby giving us a theory of conscious unity. So the basic suggestion now becomes, when you have all these things going on in your sensory system, the ones that get unified together are the ones that constitute the same conscious state. The ones that constitute the same conscious state are the ones that are flickering at the neural implementation on and off at the same frequency. We might put this a little bit more carefully by saying that across sensory modalities, bound states need not be in perfect synchrony, but need to be phase-locked, which is to say, if you look at the cycle of gamma oscillations going on in one sensory area and compare them to another, what you should hope to find is that the pattern you see in one is linked to the other, such that any particular position in one will have a corresponding position in the other. So it might not be that the peaks of the synchronized firing in your visual system align with the peaks of the synchronized firing in your auditory system. But you should be able to superimpose the two patterns of oscillation and show that they bear a systematic relationship, such that maybe the low points in one correspond to the high points in the other, some kind of locked phase. And that's, in fact, what you do find. So there's pretty good evidence that during cases of intersensory perception, and also within the same modality, if you look at different stimulus features like color and shape, you will find this kind of coordinated activity. Now, I've been talking about spatial unity, which is to say, I've been imagining that we're looking at a complex scene at a particular moment. All those elements are bound together in a single percept here and now. As a kind of aside, I want to mention that there's another notion of unity, which has to do with integration of experiences over time. And while this is a large topic that warrants its own discussion, I just want to indicate that a synchrony story of spatial unity could also be appropriated in shedding some light on the phenomenon of temporal unity. The basic idea behind temporal unity is that moments of experience are not punctate. They're not extensionless points. Rather, they seem to have a kind of temporal breadth. We can ask, how long is the conscious moment? In fact, that's a perennial question in philosophy. And we ask that, we're assuming that there's a sense in which something occurring at the beginning of a conscious moment may be part of the same experience, may be the experience as a whole, together with something that occurs at the end of that moment. So if we think about moments as a kind of temporally extending building block, we might say consciousness is temporal breadth, where that means within a single conscious moment, more than one experience, or a changing experience can qualify as a single experience, can be unified together as a whole. Now, in asking for the duration of the moment, I think it's going to turn out that there are multiple kinds of answers we can give, because people might mean different things by the moment. There are different ways to measure what moments are. Now, one notion of the moment that might be arbitrarily called the present refers to a kind of long temporal interval, maybe connected to what James called the spurious present, which has to do with our general impression that there are certain things that qualify as going on in our life right now, and other things, or in our flow of experience right now, and other things that are clearly in the past or clearly in the future. Now, when you ask about the present in that sense, the present need not be an instant. It need not be the kind of moment that seems to be parceled together to us as consciously occurring, as it were, all at once. The present might extend to include something that happened a moment ago. So when uttering a sentence, the first words in my sentence might still seem like they're part of the same present that includes the last word in my sentence. But the sentence I uttered a minute ago or in the last paragraph, that counts as the past. So what is the kind of temporal unit that includes the words in an entire sentence, that can extend that long? Here I think there's pretty good reason to think that the duration of the present is not, say, 12 seconds, which is what James estimated, but maybe something more on the order of 2.5 to 3.5 seconds, a number that crops up in many studies of temporal awareness. It crops up as a standard unit of time in measuring, say, how we sequence events. So if you think about a complex event like making a bed or boiling water, the various stages that occur in making up that event. And it turns out that human and also non-human animal actions tend to parcel up into these kinds of 3-second units. It also looks like it's the duration of accurate memory. If I play a melody for you, you can reproduce that melody quite faithfully, but only if it's about 3 seconds. If it extends beyond that, your fidelity drops off precipitously, suggesting that 3 seconds is a kind of accurate store, the period in which we're retaining information with a high degree of sensory fidelity, but beyond that we can't. One more example. If you look at a bistable figure, like a necrocube, you will spontaneously shift from one interpretation to another. The duration of endogenous spontaneous shifts, that is, if you don't try to shift attention, but just sit there looking at the figure, the duration between shifts tends to be about 3 seconds. One explanation of this is that the 3-second interval is a kind of attentional resetting time. It's a time in which we have figured out a particular attentional set, stuck with it, and then after hanging with it for a particular interval, we shift to another. And when you're presenting a stimulus like a melody, you can attend to it for the duration of that period, but if your melody exceeds beyond 3 seconds, our spontaneous shifting leads us to lose our memory and to stop encoding faithfully. You can see this, for example, with a phenomenon called inhibition of return. If you attend to one stimulus, it's actually difficult to re-attend to it for a brief temporal interval. It's as if we've kind of demarcated out of an attentional memory that we've already been there, and it's not advantageous to re-explore that region of space for a little while until we assign ourselves a new attentional task. It turns out that the inhibition of return also has a duration of about 3 seconds. So something about the kind of attentional resetting that involves also information flow to working memory where chunks of information get stored seems to account for what we characterize as the present. The duration of a typical sentence might fall within this time frame as well. But there are other units of temporality that we can also think of as the moment. So I briefly mentioned the word the instant, and I said the present is longer than the instant. And what I had in mind is that there is a sense that even these things we'll consider the present might break down into smaller parcels. When I say something just lasts an instant, what I'm referring to is a kind of smaller unit of time. And one might think of an instant as the kind of temporal duration in which we can see some chain of events happening. Think about it this way. An instant might be a kind of minimal duration in which we can maybe see cause and effect, or discriminate two stimuli as being different from each other, one than the other. That is an experience of succession. They're both bound together as a single moment. When we experience succession, there's a sense in which that's one moment, but it can be an instantaneous moment. So let's, by stipulation, define the instant as the minimal duration in which succession can be perceived. And it turns out this works out to be on the order of about 100 milliseconds. Within that interval, if there are two stimuli presented concurrently, we can tell that there are two stimuli, and we can tell that they are ordered, and we can even tell the order in which they occur. Shorter than that interval, this becomes difficult or impossible. And that brings us to, I think, a fundamental unit, which would be the bare minimum at which experience can occur in time at all. And let's label that the now. And what I want to suggest, based on the psychophysics here, is that it's reasonable to think of the now as something on the order of 25 to 30 milliseconds. And the reason for this is, if you look at studies of our capacity to perceive stimuli that are briefly presented, 25 milliseconds looks like a crucial cutoff point. With mask priming, if my stimulus is shorter than 25 milliseconds and followed by a mask, it will be invisible. But if it's longer, I can detect that a stimulus was presented. At 25 milliseconds, I can't detect much else. If two stimuli are presented within that interval, I can't tell that there were two. If I have a 30 millisecond or maybe a 50 millisecond presentation, I can tell that there are two, but I can't distinguish the order of them. I don't know which one came first. So within this kind of time frame, 25, 30 milliseconds, we are perceiving things consciously. It's the threshold for having any conscious experience at all. And we can even experience something that has temporal breadth, a tone that has a temporal contour. But we haven't yet been able to order these things into some sort of coherent sequence. Now, that can be thought of as the now. Now, the reason why I said all this stuff about time is it relates back to the theory that unity is synchrony. Consciousness involves 40 hertz oscillations, I conjectured. 40 hertz, a 40 hertz beat, a gamma beat within an oscillating neural population, has a duration of 25 milliseconds. So we might put these pieces together and say the reason why we experience things at a minimal duration of 25 milliseconds is that's the time we need to get a full gamma beat in. The reason why we start to experience something like succession only when we have longer intervals is stimulus detection occurs at 25 milliseconds, but discrimination, differentiation, ordering requires a couple of these gamma beats. In fact, there's some evidence, if we go back through our different sequences of time, that this unit, the instant, which lasts for about 100 milliseconds, also relates to processes within the nervous system that involve gamma synchrony. Now, it turns out that gamma synchrony has a tendency to nest itself in other patterns of neural oscillation. And you can show that where you have gamma beats, they tend to be correlated with and nested within longer, I should say slower oscillation frequencies, like the alpha range. And the alpha range is basically 1 every 100 milliseconds. So you might think the alpha range is a kind of synchrony that plays a role in organizing the gamma responses. And one reason why we might have these temporal units that I labeled the instant, which are already units within which succession can be perceived, is that we have gamma being orchestrated by these slower frequencies, alpha. And it turns out that if you present a stimulus or a changing stimulus at the low point in one of these alpha cycles, you often get perception failure. So we might end up with a story according to which attended stimuli are synchronized gamma, and then there are other control structures that play a role in generating these gamma responses and orchestrating them that occur at different frequencies that play a role in parcellization of experience. With respect to unity over time, you might say at a minimum the instant, a single gamma beat, is unified, and we might think of these control structures that lead to the processing of gamma over a particular cycle as giving rise to the view that an interval within which you have a gamma succession, an interval generated by one of these alpha beats, can be thought of as well as a kind of unified unit. So the idea there is that the gamma processing that occurs over a sequence of gamma beats is itself orchestrated by a common process and therefore counts as a kind of unified attentional set. This is a period, a temporal period, in which the control structures that give us attention to one item in the period are directly related to the control structures that give us attention to the next item within that interval. So I think the gamma theory of attention can be used to ultimately shed light on the unity in time as well as space. I want to say something briefly about how this approach to unity compares to other theories of unity. One theory of unity that has been entertained in the literature is associated with the Kantian tradition, thinks about unity as involving the self. And the basic idea is that there's a kind of co-ownership of experience. Two experiences are unified together if and only if they are perceived by the same experiential subject. And I am not going to critically review this alternative here, but I simply want to register a possible advantage that the attentional approach would have. Selfish unity, the idea that consciousness comes when you have a unified self, is saddled, obviously, with a commitment to something self-like. It's committed to the view that there's some kind of inner perceiver that's playing the role of recipient within the flow of conscious experience. And I don't think that that's something we should be saddled with. For multiple reasons. One can imagine all kinds of skepticism about the self. One can imagine a skepticism about the self as a subject of consciousness as opposed to the self being the entire brain or all of mental processing, conscious and unconscious. One might worry that the recipients of our conscious states, namely working memory store structures, are actually plural. There are many of them, different ones for different sense modalities. So if we think about consciousness as being broadcast to something, it's not being broadcast to a single thing. It's being sent to multiple things, multiple working memory stores. So it doesn't look like there is a single place where consciousness comes together to a common receiver, either psychologically or biologically. So I think this idea of trying to create unity through the self, whatever one might want to say about it philosophically, fails on empirical grounds to be a very promising strategy. Another approach to unity involves a suggestion put forward by Michael Tai and others that unity is a kind of primitive, that really we shouldn't think about the question, how does consciousness get unified? Because that leads us into a view of consciousness that's overly atomistic, where we have a bunch of different components that need to get pieced together. What if you assume that as a primitive, that consciousness is unified, the conscious states are always a single whole? There might be a question of how we can focus in on any part of that whole, but consciousness is given to us holistically in a way that defies even the articulate raising of a question, a problematized question of how this stuff gets parceled together. Now, from a point of view of phenomenology, there's a certain plausibility to the primitive unity view. From a point of view of cognitive neuroscience and psychological processing, it seems sort of hopeless, which is to say we know overwhelmingly, extremely compelling empirical evidence that the contributions to a conscious experience within the brain are widely distributed. So just from the point of view of the level of implementation, there's a question about how all this stuff gets pieced together. And maybe you could say, look, the Synchrony story is a good account of unity at the level of implementation, even if the holistic story, the primitive unity story, is the best account of the phenomenology. And there may, in that sense, be room for a reconciliation between these approaches. On the other hand, I think the claim that we have a phenomenologically unified whole that's primitively unified is also open to critique. It's not obvious that when you think about the structured character of experience, that we should think about this as primitively united. After all, it's very easy to identify and name the parts of experience, and it's very easy to think about how those parts can remain constant across variations in the rest. A single object in your experience might remain perceptually unchanged as the background and surround objects change. Now, to that extent, a kind of holistic story doesn't seem to be the best account of what it's like to preserve experience of a single object. It seems like there was some item of experience that's the same under both of those conditions. And I think atomistic theories which think about consciousness as building together whole experiences from separable parts makes more sense in those kinds of cases. That said, I think to the extent that there's a phenomenological intuition behind the primitive view, we might think there's something that we need to account for. That is, to the extent that from a phenomenological perspective there's a way in which all the items in our experience seem like they are currently part of a whole and we need to do a bit of work to separate one from the other, that would suggest there's some kind of story that would need to be offered. And what I want to suggest is not that the primitive unity theory is strictly mistaken, but that there's a way in which its polarized status, the suggestion that it's incompatible with an atomistic theory, is something we don't need to accept. And the synchrony theory gives us a way of showing that the dichotomy between holism and atomism might not be especially meaningful in the context of conscious experience. So here's why. Think about holism and ask yourself, is a collection of neurons firing in synchrony a holistic state or an atomistic one? In one sense, it's holistic. The very fact that we have a pattern, synchronized neurons, suggests that there's a single whole there, coherent whole. It's rendered coherent by the fact that there's a certain oscillatory pattern that unites the whole group. But it's also atomistic. We can talk about each population within this large constellation of neurons. We can talk about what information each of those is carrying, and we can even shift the allocation of attention so that that window of synchrony shrinks down to one particular stream within this complex whole. So I think with respect to synchrony, we can see room for both thinking about consciousness as a unified whole, a population of neurons that count as one in virtue of having the same dynamics, but also a population that can be thought of at the level of atomic parts. So the synchrony theory, I think, has some advantages over these other kinds of views by providing much more detail with respect to the levels of implementation, but also shedding light both on the phenomenology and giving us a concrete account of how the complexity of the nervous system could, in some sense, be said to realize a single whole. I want to end by considering two implications of the theory that consciousness involves temporal unity. And the implications are going to bring us back initially to the claim that we put forward at the beginning about the possibility that consciousness is always everywhere unified. That was the Unity Thesis. Now, I've said nothing that directly contradicts the Unity Thesis. But what I want to suggest is that if you think about the view that consciousness is attention, and think about the claim that attention is neural synchrony, it seems at least possible that we could get a disunified stream. It seems at least possible that you could have disunity within your conscious state. Certain neurons could be firing at one frequency, others could be firing at a different frequency, and they would both be conscious. There's nothing about the implementation of consciousness on this theory that disallows it. Not only is it not disallowed, but there is a huge amount of research suggesting that attention has multiple control structures. Different parts of the brain can play a role in allocating attention, and under the same circumstance, you might have these different structures allocating attention in different ways to different bits of the stream, depending on the particular information processing roles that our very complex nervous system needs to play. So in these kinds of cases, you might actually imagine that the physical machinery of your brain would allow and even favor a kind of disunity, separable processing of equally attended information, just not co-attended. And it's very hard to find clear examples of this from ordinary experience, but some examples that suggest themselves include the cases of background noises. So Ned Block has publicized the possibility that we might be conscious of the hum of an air conditioner, even when we're not particularly paying attention to it. Where paying attention means something like making an executive decision to focus on that. On my perspective, on my view that consciousness is attention, what I say about the air conditioner hum is we're attending to it, but we're not choosing to. That is to say, there's some allocation of attention to it, but it's not the focus of our current executive allocations of attention, which are based on whatever the task demands of the situation might happen to be. So when you're listening to a lecture, your task demands don't require recording anything about the air conditioner, but you still might allocate a kind of ambient attention to your surrounds to remain aware of things that are occurring around you that might not be especially important now, but might become important. Thought about in terms of the phenomenology, we could characterize this as being conscious of the lecture and conscious of the hum, but not co-conscious of the two, because we're not co-attending to the two. at the level of neural implementation, what we want to look for empirically is neural synchrony for both stimuli, but no phase locking between those stimuli. Another example from experimental psychology comes from research on illusory conjunctions. So Ann Treisman and others have presented stimuli like this, where a subject is very briefly presented with an array of shapes or letters that have form as well as color. And after being presented with this array, people are probed to record or recall all of the objects they saw, both in form and color. And when this happens, people make errors. They are quite confident they saw a certain letter, say a G, and they're quite confident they saw a certain color, say orange, but they don't know if the orange was on the G or on the L or on the A. And what seems to be going on in these cases is our color perception stream and our object shape perception stream have both been recipients of an allocation of attention. They've both led to conscious percept, but these have not necessarily been integrated together. This could be a binding phenomenon. So what I'm saying here is not in any way demonstrative evidence of disunity. I just want to open it up as an empirical possibility that we might think of some of these cases as cases where at the moment of perception there are actually two separable conscious streams. There were two allocations of attention that were independent of each other in their oscillatory profile, resulting in a disunified percept. There's been quite a lot of discussion of cases of split brain patients, the suggestion being that when you separate the corpus callosum, you may end up getting two separable streams of consciousness. I think the neural synchrony view does not entail that. There is evidence that attention can be allocated in some centralized way, even in split brain patients. So under certain conditions, you can get one hemisphere competing for attention with another hemisphere, suggesting a common locus of attentional allocation even after the corpus callosum has been sectioned. But under other experimental circumstances, it does look like split brain patients can attend separately and independently to stimuli presented in the two hemispheres. In terms of perceptual reports, we know that dichotic presentation of a word that has several parts, like key ring, tends to lead to an interpretation that doesn't integrate the two parts. So the participant in this study would register having seen key and having seen ring, and not the unified meaning of key ring, suggesting independent streams of perception. And I think that, together with information that attention can be separately allocated, might lead us to think that these patients have separable streams of consciousness as well. It's been suggested by Tim Bain, among others, that actually an alternative interpretation is that you have one stream of consciousness, but you have a kind of switch that flickers back and forth between consciousness being located in the right hemisphere and then in the left hemisphere. And I think that's an interesting hypothesis, but I think it suffers from two problems with respect to the approach to unity that I have been advancing. One of them has to do with the temporal unity between the switches. So it's not clear that if you had a switching story, you would be able to say that the percept in the left hemisphere and followed by a percept in the right hemisphere constitute a single unified percept extended over time. And to that extent, even the switching story won't give you full unity because it won't give you temporal unity. And Bain has some interesting things to say about that. But another kind of worry has to do with the temporal dynamics of switching. Go back to the observation before, that the time course of shifting from one percept to another in presentation of a Necker cube is on the order of 3 seconds. Turns out the same is true for dichotic viewing. So in a healthy subject, when presented with two different stimuli, one in each eye, if the stimuli are equal in their intensity, people will experience the two successively, like a switch. So there does seem to be some switching mechanism, probably attentionally guided, that allows you to go from one stimulus to the other. There's a lot of evidence suggesting that these shifts in binocular rivalry experiments involve shifts in attention. So far, so good. But the time course of these shifts, again, tends to be quite long, 3 seconds. If you think about the presentation of two stimuli in a tachistoscopic display in a split brain patient, we're talking about a couple hundred milliseconds. Maybe with iconic memory, you can double that time, even if you get up to a second zone. It's not obvious that this is enough time to get an intentional switch. In fact, even if it were enough time, even if we could shift attention that quickly, if we tried to, there's no reason to think that under an experimental condition where the subject isn't instructed to rapidly switch attention, that such a rapid shift would occur. Nevertheless, these subjects reliably report or respond to stimuli presented in both eyes. So I don't think a switching story understood as an attentional switching story makes sense temporally with respect to the phenomenon. To summarize that point, split brain patients show capacity to perceive stimuli that are presented simultaneously for brief temporal intervals. If there was one stream of consciousness that shifted from one stimulus to the other in succession, we shouldn't expect them to reliably to perceive two when they're presented for such short intervals, because attentional shifts tend to be slower than that. Okay, a second and final implication. There is a phenomenon or a metaphor that's used in cognitive studies, the refrigerator light illusion, which refers to the view that we sometimes attribute things to consciousness that are not necessarily true of it. They just happen to be there when we look for it. So the idea is that like the light in the refrigerator, which we might surmise is always on, it turns out that the light goes on only when we open that door. So what I want to suggest is that unity might be like the refrigerator light, which is to say, it seems to many people phenomenologically obvious that consciousness is always unified. The Unity Thesis seems to be obviously true from a point of view of introspection. It's extremely hard to identify actual cases in experience where consciousness becomes disunified. I made some efforts to do that, but there are always other interpretations. I think if the attention theory is right, there's a principled reason for this. And the principled reason goes as follows. Suppose you're interested in whether two stimuli are part of a unified experience or experience separately. So maybe you're experiencing a sound and you're experiencing something visual. And you want to know, is this a single experience or am I having two streams of consciousness? Now, if you're not actually asking that question, it's impossible to answer. Imagine walking down the street listening to your headphones. You might have all kinds of visual experiences of the traffic and the sound of the music. Are these two streams of consciousness or one? Before you've asked the question, it's not obvious what the answer is, or even whether the question can be answered. But if you ask the question, something happens. You try to examine both together. How else would you answer the question, are these unified? You need to attend to the two of them. Now, if you're doing that, if you're comparing two experiences and asking whether they're part of the same experience, you're allocating attention to two things simultaneously. As soon as you do that, you get neural synchrony across the population of neurons. That means when we look for unity, we generate unity. Whenever we try to figure out whether conscious states are unified, we impose unity on them. So the disunity of consciousness can never be directly examined. It always needs to be caught in the periphery or inferred. A better analogy, better than the refrigerator light, might be this. If you're a military officer, your troops may be extremely obedient. Or if you're a teacher, your students may be extremely obedient, such that when you enter the classroom or when you enter the troops, the area where the troops are standing, they'll all stand to attention. They'll all align themselves perfectly and look perfectly well-behaved, organized, and synchronized with each other. But when you leave the room, chaos may break loose. The students may all act in different ways. They may get involved in their own separable projects. There may be very little unity. So if you think about the search for unity from an introspective perspective as being a kind of teacher or drill sergeant who enters a public space with obedient followers, you can imagine that we'd never see unity when we looked for it. We can only catch it when we sort of peer in from the side. Okay, so in conclusion, what I want to suggest is that the claim that consciousness is attention lends itself very naturally to a particular theory of unity. That theory arises because of a story about the neural implementation of attention. Attention seems to be realized as synchronized neural activity. Synchrony doesn't only explain how attention works, that is, how information flows from perception to working memory. It also explains how various different parts of the nervous system can coalesce together at a single moment and become part of a single experience. So we get out of the theory of consciousness as attention a theory that unity is achieved by neural synchrony. But if that theory is true, it's an empirical possibility that there might be, at any given time, multiple streams of consciousness, different parcels of neurons firing together in unified packages, but two packages of synchrony that are not synchronized with each other. That possibility seems perhaps difficult to support by introspective evidence, despite some suggested cases, but there's a principled reason why that might be so. Unity is something that we can never, disunity is something that we can never discover by introspection, because as soon as we look for it, it disappears. When we look for unity, we'll always find it, even if the mind, even if the streams of consciousness are highly disunified in the ordinary waking state. And with that, I'll end, and thank you very much for tuning in.